Hi my friends, this tutorial is a follower of the previous one, and it deals with dynamic simulation. In the previous tutorial we ended with the collision, and now I want to detail this aspect of dynamic simulation. As you can see, here is the pendulum single, a component of the pendulum assembly, and this face and this face are in the same plane. Look, yes, they have the same, the two end cylinder have the same thickness, 12 millimeters. Okay, I select this and you see some two yellow circles and the point. These are present because I'll show you something what I told about. In the sketch application option starts with general. In the sketch tab, this line is checked. Yes, auto project edges for sketch creation and edit. If this is unchecked or disabled, then that circles don't appear. Yes, I can delete them by pressing the key delete from the keyboard. No problem. You choose what solution is best for you, with or without checking that option in application options. Okay, now I project this exterior circle, not this one, a generator and another one, and the other exterior circle. And now I create an arc with a center point. This is the center. I start from this point. You will see why I make this. You see now the remaining yellow segment, and we do this same in the other end. An arc with this center starting from here, trigonometrical, and the remaining arc is present. Now we have a full contour here, and I make this, the full circle, constructive. The same here. Okay, we have this sketch now. This component now has a new sketch here. We save it, we close the component, and we open the pendulum, the assembly with pendulums, with both pendulum. We are advised that a part was changed. Okay, I know it is changed. The sketch will be present in the both pendulum. You see them here. Yes, both on the same side of the pendulum single, and both in the same plane. This is important. We see here some marks. This means that we have to update these sub-assemblies, and we do this by using local update, a new thing in our tutorials. Now they are up to date. Good. We go further by trying to create join contacts with these two sketches instead of the cylindrical part or the projection of a face of it, what we did in the previous tutorial. This didn't has history. This assembly pendulums is new. It has no history with dynamic simulation, so we have to start from the scratch with dynamic simulation. We have to activate gravity. We know the procedure. We did it before, and we start movement. It's okay. Now click here to eliminate the vector. Click on the name. I want to discuss a little about what is here in the browser. Here you can see that grounded is the pendulum number 1 in red on the screen. I go here and you see red in the screen on the right pendulum. And the welded group. What is this welded group? Grounded. The welded group is the stand, but not only the stand, but two components, stand and the axle, the long axle, which means this one. Yes, this and this are two components, this one and this one. Yes, you see here, which are considered by the dynamic simulation module as being welded. They are not moving one or the other. The same welded are here, yes, between the pendulum double and this axle. Look here, pendulum double and the short axle, pendulum double, short axle. You can understand that in dynamic simulation some parts are mobile and some are fixed. The fixed one are grounded. The mobile are parts or welded group of parts. That's all the explanation. Good. Now we have to add that joint. We select 2D contact. You have to see the previous tutorial where I explained these things. And we choose now the two sketches. Yes, the first curve is the first sketch and the second one is the other sketch. They are both external. The vectors are external. Yes, this is important because we want to study collision in the external. You see, this is like a bone, yes? A bone with two cylindrical ends. This sketch. And all the vectors here are to the exterior. No one is in the interior. A contour can be in contact with the external parts or internal parts. And you can change this vector to be inside when you intend to create an internal contact. I try to make for you detailed assembly to see what happens, but I don't promise this. Okay. Now let's see what is the result. We we are in construction mode, yes? See what we did yesterday. And now I drag this end, and I see that there is a contact. Yes, I can see this very, very well. Any part with any other part. Let's go to start the movement. We place a trace of color orange to the left pendulum, apply, and the color to be blue, dark blue. On the other, and another trace with the color blue, dark blue, here. Okay. Now we change here to 5 seconds and here 2500 images in total. Okay. This is a total random situation, and I hope to obtain more than one collision. Now I put this to pendulums in position to be favorable to a collision or more than one. And I start the movement. Okay, the first is good. Now the second. Okay. it seems to be all. Yes. The data are collected. This is the stop after collecting, and now we can use output grapher to see, you know, from the previous, to see velocity, to see acceleration if we add them to the trace. I was interested in a special position. Look, I go to constructive, I bring this pendulum somewhere here or here, and the other in a position here. You will say, oh, but why this is not a collision? This is not a collision. Look why. Because they don't collide. This is why. One pendulum is moving inside the double pendulum. Of course, if I go further, this is a collision. Yes? And this is another collision. A lot of collisions here. You see what happens. I start here the movement, and they are in collision. It is very interesting, and I think that you now are well informed about this side, this domain of Inventor. What is important is that, and I'll show you also this. You see a moment of stop. That is the final of collecting data by the system. I want to show you something. I want to show you that if I go to the beginning and I put one up and one down per total, you'll see a minimum movement here and a great here. Why? Because this is a potential energy of the pendulum, because it is up, and this is a small energy, a small potential energy here. This is greater than this, and you see very well comparing the two. No collision, but it comes. And the right one give some energy to the other because of the collision. I want to mention especially that I didn't place any friction. Yes, this is moving without end, eternally, because nothing is opposed. No friction, nothing. This is not natural, of course. But this is why we are studying ideal systems to have all the picture with or without friction. That's enough for today. Bye-bye. The last thing I want to tell you is that you can make invisible that sketches and the contacts will be not affected. Yes, these are the 4 contacts between, not this, excuse me, this only one 2D contact is created here. These are what I told in the previous, these are standard joints. We added a contact joint. Look, I go to the assembly, the pendulum single, and I make not visible. This is not important in our study. It's important in general to make something not visible. You disturb the representation. You have here representations, and these are important, but not in this case. So we can remove associativity for our purpose in this case. Good. We go back, and this pendulum single has no sketch attached. We go to the other. The other is this one. This is the single, double click, and also not visible with this observation. Return. Go to environments, dynamic simulation, see from the front, and start. You recognize positions high and down. The same movements. Yes, absolutely the same. There are many things you can make with this beautiful simulation. One of them is to save this contour. Yes, I wait for you to tell us how to do this. How can I save this contour to use in another context? I wait for you. I'm curious if anybody of my viewers or subscribers will answer to this question. You will see in the comments of this clip on YouTube if somebody is answering to this question. I found some time for you, and I created 3 parts which I am now placing in an assembly. This is the first. Its name is CAM internal. Another one is CAM external. And a roller. 1, 2. This is fix. Okay. I apply constraints for both to be at the same level. Their up surface, apply, and then the distance from one to each other, not roller, excuse me, but CAM internal, this plane, with CAM external, the same plane, at 220 millimeters distance. The other constraint is alignment between this plane and this center point. Okay. Now I place, you see these 2 roller are in the air. So I place them at the same level with both parts. Respectively. Okay. Good. Now they are in the same plane and I cannot move them but in plane. Yes? Inside, outside. Say this position. And now we apply dynamic simulation. First thing is gravity. Double click. Not an entity. I don't have an entity to be chosen as the direction, so I use the same value like here, 9,110, the natural gravitational acceleration in millimeters per square second. You know this. Y is this direction, yes? And I place the gravity in that direction. This means that we have to look so to our 2 groups of elements. The gravitation is so. Okay, I choose 5 seconds and here 5,000 images, and I start movement. Take a look. Be very careful to see the situation, yes? Look. Nothing is here to make them not to be in movement forever. I change to perspective, and you will be now more interested in seeing this. Look. This is the best position. Look. Okay, why happens this? Because there is nothing, not any constraint for them to move. If I go to constructive mode, everywhere in the space, nothing stops them. Okay, then let's insert a 2D contact join. This is the profile for this roller, and this is the roller. Apply. And for the other, this is the internal contour, and this is the roller. Okay. Now F home to have the same position. No, I can put this, and no perspective. Why perspective when we don't need to see other? Now the situation is very simple. Look. Remember that there is no friction at all. Well, why did I show you this? Because I want you to see that this contour is with vectors in this direction, and the other one is inside. Yes, we can have a roller to move inside a contour, and we can have the same roller outside the contour. And this is why you have to change the situation if they are not conform. Look what happens. I select properties and I change this. Yes, this. This is not natural. Now the roller wants to be here. Yes, to be in contact with the other. Okay, let's see what happens. Impossible to solve the system. Yes, check the definition 2D contact 4. This is contact 4. Okay, we go to contact 4 and we change the normal. There is another normal here, but we don't are interested in. Okay, that's all. Now my promise is fulfilled, because I told you during my presentation that I want to tell you about this. This is all for today. Bye bye.